Okay, this is the second video going over problem 3 from the notes for section 3.6. We're ready to do our second derivative analysis. Our first derivative was 2x minus 12 over x minus 3 to the 3 halves. So now I'm going to do the quotient rule again. So my second derivative is the denominator x minus 3 to the 3 halves times the derivative of the numerator minus the numerator times the derivative of the denominator, which would be 3 halves x minus 3 to the 1 half, over the denominator squared, and if you square something to the 3 halves, you get it to the third power. Okay, again, I'm going to be factoring out the greatest common factor between this term and this term. So first let me clean those up a little bit. It makes it easier to see. So the first one is 2 times x minus 3 to the 3 halves minus, if I actually multiply the 3 halves times the 2x minus 12, I believe I get 3x minus 18. And then I have an x minus 3 to the 1 half. Okay, the greatest common factor is going to take the lowest power of these x minus 3's. So I'm going to take out an x minus 3 to the 1 half. That leaves me with a 2 times x minus 3 minus the quantity 3x minus 18. And it's all over an x minus 3 to the third. Okay, so again, I can move this x minus 3 to the 1 half. I can combine it with what's on the bottom. If I move it to the bottom, it'll be a negative a half on the bottom. So if I take 3 and subtract a half, let's see, that would be 6 halves minus 1 half would be 5 halves on the bottom. So I'll have x minus 3 to the 5 halves on the bottom. On the top, if I simplify all of this, if I distribute, I get 2x minus 6 minus 3x plus 18. So I believe I get negative x. Let's see, that was minus 6 plus 18 should be plus 12. Okay, and again, I'm going to either set that equal to 0 or undefined. It's undefined when x equals 3, which is not part of my domain. So if I set the numerator equal to 0, negative x plus 12 equals 0, I get x equals 12, which is part of my domain. So I do the number line sign chart for f double prime. Remember, I'm only starting at x equals 3. That's part of my domain, or greater than 3. And I put 12 on there. Okay, if I pick something between 3 and 12, like let's say 10, looks like I'm going to get a positive. Pick something over here, like let's say 15. Looks like I'm going to get a negative. All right, so then what does this tell me about the shape of the curve? It tells me about concavity. So f is concave up on the interval 3 to 12 and concave down on the interval 12 to infinity. Then I have a point of inflection at x equals 12. And again, I'll plug 12 into the original problem. So take just a second, plug 12 into the original problem, and I believe I get 16. Okay, hopefully I haven't made a mistake there. Okay, now I'm ready to take all of the information and put it together. So the first thing I'm going to do is I'm going to do that double number line sign chart that we talked about, where f prime goes on top and f double prime on the bottom. Whole thing starts at 3. The only 0 for f prime was at 6, and the 0 for f double prime was at 12. Okay, so between 0 and 6, f prime was negative, but I can see from here that f double prime is positive. From 6 to 12, f prime turned into positive, but f double prime was still positive. Past 12, f prime is still positive, and now f double prime is negative. So again, what does that mean? Decreasing, concave up. Increasing, concave up. Increasing, concave down. All right, now I'm ready to actually start graphing my points. Okay, so again, I know that this only exists past 3. Okay, so I kind of can only start it there. Okay, I do have a couple of points that I can actually plot. I can plot the point 12, 16. So let's say that this is 10, 20, 30. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know I can plot the point 12, 16. I also know I can plot the first derivative point, which was at 6, and then 24 over radical 3. So if I take and do 24 divided by radical 3, I get 13.8 about. So that was at 6, 13.8. It's right around there. Remember, that was the minimum. Okay, so until I get to that point, I have to be decreasing concave up, then I have to increase but stay concave up, and then I have to increase but change to concave down. And there is the graph of my function. There's my minimum, and that is my point of inflection. And that's the complete curve sketching process. It can be complex when you have these issues with domain, but the process is the same whether you're doing a polynomial or something more complex like this problem. Okay, hope that was helpful. Be sure that you have reviewed this and studied this before you come to class on Wednesday.